Dealing with operations with vectors in space, most of the stuff we do with three-dimensional vectors is nearly identical to what we do with two-dimensional vectors. We just have this extra component that we have to do the same thing to. Okay? So when we're adding vectors, before with 2 dimensions, we added the horizontal components, then we added the vertical components. Now we've got to add the z component as well. All right? When we did scalar multiplication, multiplying a vector by a constant, we had to multiply both components by that constant. Well, now we're just going to multiply all 3 components by that constant. Okay? We did it with 2 dimensions. Now we're just kind of expanding this.
I thought some of the homework had 3 coordinates.
Well, yes, but we weren't doing it was more a geometric seeing the vectors and working with just points to find the vectors. Now we're going to take multiple vectors and use them together.
But if you have 3 points, you're 3 dimensional.
If we had 3 points.
If you have 3 coordinates, you're 3 dimensional.
Yes. Now I did show you one where we did some vector addition, okay? But that was just one that I showed you there in the homework. One thing I will say though, and this is, you need to make sure that you are doing things properly and showing work properly. There is no division for vectors, okay? There's no scalar division. So I don't want to see you doing, vector u divided by 3. Now, you can multiply, so what would you multiply by?
1/3.
Yeah, you'd multiply that by that 1/3. Okay, so you can do that, but you can't divide a vector by a constant. Okay, and I know there's just a fine difference there. It's really just a matter of the terminology you're using, but it really is a matter of division isn't defined for vectors, okay? Only multiplication is.
If you multiply it by 1 over whatever, you're making it small.
Yeah, you're doing the same thing in the end, but we're just trying to be proper and use proper mathematics, proper notation, okay? One other thing that still applies, this we looked at with 2 dimensions, is the fact that if you have a scalar multiple of a vector, you can just multiply, and you're trying to find the magnitude, you can just multiply that constant, that scalar, by the magnitude of the original vector. And we'll use this a couple of different ways. Just as an example, let's say I took v, and I wanted to find the magnitude of v. Okay, we looked at this yesterday. The magnitude of v, we've got the square root of negative 4 squared is 16, plus 36, plus 25. 4 squared plus 6 squared plus 5 squared. So we have the magnitude of v, and that is 5277, square root of 77. Okay? So then if I had this other vector, let's say w, and it was negative 8, 12, and 10, that's just double vector v, right? So what's the magnitude of w? Yeah, since w is just 2v, then this is just 2 times the magnitude of v. So 2 root 77. Okay? So when you have a constant there, this is what I think is sometimes the most useful one, is if you recognize you have they're not big numbers, but bigger numbers. If you can actually pull out a factor, okay, you can make your work a little easier. Okay? Well, I recognize that these all have a common factor of 2, and if I pull that out, I have the same thing that I had when I had v.
But where can you pull it out? Like, if you pull out the 2, where do you put it? You do 2.
You're just saying that w is 2 times vector v, so since we know vector v, we can just multiply that by 2 to get the w. Here, try a couple of these. Using these 2 vectors, vector u and vector v, let's just try a couple real quickly here. What would u plus v equal? What would 3u minus 2v equal? What's the magnitude of u and what's the magnitude of 5u? Okay, so try those here on your own for a minute.
What do the bars mean?
What do the bars mean? That's what we were doing up here. Or that's the same as the length or the distance from the starting point to the ending point.
Everything added up, and then the square.
Yeah, remember it's an extension of the Pythagorean theorem. Now we're in 3 dimensions, so it's all right. So let's see. I don't know. What did you get for u plus v? And 3. Okay, good. -1, 14, and 3. Okay? Questions? I didn't think so. All right, how about 3u minus 2v? Lexi?
I got 17, 12, and
17, 12, and -4. Okay?
Is it
Is it next to
-4? I got -16 now.
-16?
Yeah.
Yeah.
Okay? So we have 3u So that's going to be 9, 24, and negative 6. Okay? Minus 2v. So minus 2v is negative 8, 12, and 10. Okay? So yeah, just be careful that you subtract each one. 9 minus a negative 8 is plus 8, so 17. 24 minus 12 is 12. Negative 6 minus 10 is a negative 16. Okay, good. All right, how about the magnitude of u?
Root 77.
Root 77. Okay? Which, notice u and v actually ended up being the same magnitude. Okay? So what does that mean?
5 times square root of
What?
5 times square root of
Oh, for this one, yes. Magnitude of 5u is 5 times the square root of 77. That's correct. Okay? Good. Now, u and v have the same magnitude. See, u is square root of 77, and v was the square root of 77. What does that mean?
They're
They are
going
the
in
same
different directions.
Same thing. Are they? They're the same length. Okay. Are they parallel?
No.
No. Okay. Does this mean they're parallel? No. Does it mean they're equal? No. If they were equal, you would have exactly the same coordinates. Here, we just have the same length or the same magnitude, but the directions are going to be different. Okay? And that's okay. Don't just make the assumption that all are the same vector or they must be parallel or anything like that. All that means is that they happen to be the same magnitude. Okay? Now, here's one similar to what we set up above. How could I rewrite vector w in a way that would make it a little easier to find the magnitude? Okay, 12 goes into all of those, right? So, if I see there's a factor of 12, I could rewrite that as 12 times what?
12 times the whole thing divided by 12, so 4 minus 6, or is it 7? Yeah, 6. Minus 6 plus 2.
Okay?
And then you just multiply 12 by whatever magnitude you get?
Yeah, and actually, notice I could even make this smaller and easier to get the magnitude with, right? Take out another 2, and I have 24, and then I'm just doing 2, negative 3, and 1, right? So the magnitude of this, okay, is the square root of 4 plus 9 plus 1. All right? So the magnitude of w would be 24 times the square root of 4 plus 9 plus 1, square root of 14. Okay? By the way, this gets us in simplest radical form pretty easily as well. Okay? If you pull out those common factors. Okay? And that's related to what we said before with the magnitude of a constant multiple. Okay? Any questions before we move on? All right. So now we have some algebra with vectors, okay? We should be able to take an algebraic vector equation and solve it for a particular vector that we want to know. Okay, so in this case, we want to solve 3u plus 2v for equals w for v. So how would I do that? You guys can figure this out. All right, let's subtract 3u from both sides. So we have 2v equals w
Minus 3u.
minus 3u. Good.
That whole side, and then you divide by 2.
Multiply by half.
multiply by half.
There we go. Good, good. All right, so V, remember there's no division. It's 1/2 times that W minus 3U. Okay? So now we have the equation and it's solved for V. And this is how you can get different variations on formulas and stuff like that. You can just, or in a situation, you can write a certain vector equation and then you could rewrite it in different forms. So like we did, remember with the shapes, where you guys were making it equal to 0, and I told you it doesn't really matter how you do it, if it's set equal to 0, or you could have it equal to one of these. They'll all be equivalent equations, okay? And they're all equivalent because we could just use the algebra to rewrite them. Okay. How would we solve this one?
Multiply 5 by U and V.
Okay.
And then subtract 5U by both sides and multiply by -1.
Okay. So we subtract 5U, W minus 5U is a negative 5V. And then we multiply by a negative 1/5. Good. All right, if you want to distribute that, you can. It'd be a negative 1/5 W plus U. Okay. If you simplify that. So, some simple algebra, but significant. We want to make sure that we know how to manipulate vector equations properly. All right. The last main thing is related to getting parallel vectors and really finding a vector ultimately with a certain magnitude in a specific direction. Okay? So the idea is this. Let's say that we have this path, this vector, 2, 8. Okay? And I want to make a vector in that same direction. The first step to doing that is going to be to find a unit vector for that direction. Okay? Now we mentioned this yesterday as we were going over the practice problems. How would I get a unit vector for the vector 2, 8? What is a unit vector?
Magnitude 1.
Magnitude of 1. Ashley? Okay, we'd find the magnitude of this. That's right. So 4 plus 64 would be square root of 68. And then do what? Okay. We're not going to divide. We're going to... Yeah, there we go. We're going to multiply by the reciprocal of the square root of 68, which this actually, that's a 2 radical 17. Okay? So it's 1 over 2 root 17 times the vector 2, 8. Okay? So notice, remember what multiplying by a constant does. All it does is change the magnitude, right? So if we're multiplying by the reciprocal of the magnitude, it's going to make the magnitude 1. All right, so now we have this vector. 2 over 2 is 1, so that's just 1 over root 17. And 8 over 2 is 4, so that's 4 over root 17. And now what we have is a vector that has the same direction as 2, 8, but the magnitude is only 1. What could we then do with that?
We could change its magnitude to whatever we want now.
Yeah, since its magnitude is 1, if I want to make the magnitude 100, I just multiply that by 100. If I want to make the magnitude 6, I just multiply that vector by 6. That's my basic direction, my unit vector in a specific direction. And then I can just multiply it by whatever I want the magnitude to be. Okay? Does that make sense? All right. So we have a similar concept here with 2, 10, and 6, or 12, 10, and 6. What would our magnitude be? Square root of 288. Okay. 100 plus 100 plus 36. Okay.
Is
Oh,
it just
280.
Yeah.
Sorry, I misheard you. Square root of 280, which would be, that's 4 times 70, so 2 root 70. Okay? So I'm going to simply take this and multiply it by 1 over 2 root 70.